This video will be a short and sweet review of the different phases of matter. So I'm hoping that to this point in your chemical education, you have heard of solids, liquids, and gases. If this is the first time you are hearing those terms, I will hunt down your former science teachers and have a few words for them. In general, we're going to look at these phases in terms of shape. Do the particles tend to stay in one shape? Can they change shape? Volume, is it consistent? Does it change? Movement of the particles, do they move fast or slow? And their energy level, do they have a high energy level or a low energy level? So in general, when I picture particles of a solid, now obviously I can't see particles of a solid, so I come up with this little particle model in my head, and I'm picturing particles that are all kind of packed real tight. They're very organized. There's not a lot of space between the particles. So maybe something like that. That's how I picture the particles in a solid. Their shape is definite. And by that I mean it stays consistent. Now obviously if I take a sledgehammer to a piece of solid wood, it can change shape. We're not talking about outside forces. Under normal circumstances, a solid tends to keep a consistent or definite shape. Same thing with the volume. It's definite. It stays the same over time. Obviously, it can change if we apply some kind of an outside force, and that's not what we're talking about. So, for example, if I have a book, that book tends to have the same shape, and it takes up the same amount of space. It has the same volume over time. And again, we're not talking about burning our books or cutting our books in half or anything like that. The movement of the particles in a solid is pretty low. For the most part, they're pretty stationary. Now, in a solid, the particles can vibrate slightly, but for the most part, there's not a lot of movement, which means the energy level of the particles is also low. These two, movement and energy, are directly proportional. If the particles have a lot of energy, then they have a lot of movement. Think about you after you had a bag of Pixie Sticks and a 2-liter bottle of Mountain Dew. Are you going to sit in your chair for very long? Probably not. You're going to have a high energy level, which is probably going to translate into you wanting to move. Same thing with particles. In this case, if they have low energy, they really don't move a whole lot. They're pretty stationary, real compact in a solid. In a liquid, that changes a little bit. When I picture a liquid in my head, I'm picturing particles that do have a little bit more space in between them. They're maybe not as organized. They're just kind of randomly floating around, hanging out. Their shape is indefinite. By indefinite, again, we kind of mean it can change. The shape of a liquid can change depending on what container I put it in. However, the volume is definite. Volume kind of refers to the number of particles, the amount of space it's going to take up. I could have 100 milliliters of water, and I could pour it into different containers. I still have 100 milliliters of water. The volume is the same. I have the same amount of water molecules. But because there's a little more space in between the particles of a liquid, those particles can flow. They can change shape depending on what kind of container I put it in. The volume will not change. It'll always be 100 milliliters or whatever the volume might be. I'll have the same amount of particles. But because there's more space between those particles, they can flow and take on the shape of whatever container I put them in. The movement and energy level, I'd maybe use this moderate for liquid particles. They can flow past one another. So there is movement with particles in a liquid. I mean, they're not bouncing around like crazy, But there's definitely more energy in a liquid than there would be in a solid. Now I'm going to see particles starting to move, which means more energy. So then we hit the gases. Gas particles in my head, I picture them being crazy. So we've got particles that are pretty far apart. There's a lot of space in between gas molecules. They can move all over the place. They can bounce off each other. They can bounce off the walls of the container. High energy particles, which translates into lots of movement. We'll get those right away. Later on at the end of the year, we'll talk specifically about gas properties a little more. But with these particles moving so much and with them colliding with each other and colliding with the walls of the container, it creates pressure, which is a measurable property of gases. The shape and volume then, let's say both of them indefinite. Indefinite. They can take on the entire shape of the container and the entire volume of the container. Little different than a liquid. So for example, let's say I have a liquid in a flask. Oh, there's a good looking flask. So here's my liquid in a flask. It takes on the shape of the container, but not necessarily the entire volume. You know, it's a set volume. It might be like 100 milliliters. So this might be kind of like a liquid in a flask. Now let's say I have, they're not quite the same. But we get the picture. It's another flask. If I fill this flask with a gas, the particles will fill the entire shape and volume of the container. So it's not like they're just stuck in the bottom like a liquid. I only have 100 milliliters. Now these gas particles are going to take on the entire container, the shape and volume, the entire volume. Arguably, there is another state of matter which sometimes causes a little confusion. There's always somebody that'll be like, what about plasma? I heard about plasma. And in their mind, they're thinking of plasma as like slime or some kind of gooey substance. Or they'll say like, what about the plasma in your blood? Well, that's really not a fourth state of matter. Like the plasma in your blood is made of little solid particles that we can filter out and we can study in blood. If you're talking plasma as a potential fourth state of matter, it's kind of like superheated gas. It's like beyond gas, where now we've got particles under such extreme heat or pressure that they may even start to break apart. The atoms themselves may kind of break down in their component parts, like protons, neutrons, electrons. We might lose electrons and keep the nucleus intact. Think of plasma as like beyond gas, super energized gas particles, where now the atomic structure itself is in jeopardy. We might start breaking apart the atom. Best example, like the sun and the stars. I mean, there's tons of like nuclear reactions happening in the sun. That's kind of what this plasma is referring to. In a couple weeks, I'll show you something, I guess, kind of similar. The best we can do. I'll take these tubes of gases and we're going to electrocute them. We'll hook them up to an electricity source and they're going to glow. So like while we're electrocuting the gas particles, it sounds so cruel. We kind of have a plasma, if you think of it as like a super energized gas. Otherwise, the main states of matter that you would need to be familiar with are just the solid, liquid, and gas.